Okay, so number 3, x plus y dx plus x plus y cosine y dy equals 0. You just have to recognize that it is an exact equation, and then to test it, you do dm. The equation's in the form m dx plus n dy, so x plus y is equal to m, and x plus y cosine y is n. So the partial derivative of m with respect to y, is that equal to the derivative of n with respect to x? Well, the derivative of x plus y with respect to y is equal to 1, and the derivative of x plus y cosine y with respect to x is equal to 1. Since these are equal, it's exact. So then, basically, the solution is you basically integrate this equation, right? Well, just the first one. So I did the integral of x plus y dx. Hang on. And basically, this whole thing up here is f of x or f of xy. Yeah, f of xy, because it's depending on both x and y. So the integral of x plus y dx is equal to 1/2 x squared plus xy, because y is not, well, you're integrating with respect to x, so you're going to put an x there. And then instead of putting a plus c after the integral, basically this is like implicit. It's like the implicit solution. So you're going to, instead of constant c, you're going to put gy. And then basically you're going to now take the derivative of this whole thing. So g prime of y. You're going to take the derivative of this whole thing with respect to y. So g prime y x 0, and then df of xy with respect to y is going to be this, your x plus y cosine y. So then you basically plug in x plus y cosine y in right here for that. So x plus y cosine y right here. And then you have your g prime y plus x here, and then you can move it over, the x over, and get rid of it. So g prime y is equal to y cosine y. And now to get g of y, to plug back into your solution here, you're going to integrate that with respect to y. So to integrate that, it's integration by parts. So you have integration by parts is the integral of u dv equal to u v minus integral of v u. Basically, u is equal to y, dv is equal to cosine y, du is equal to y, and then in cosine y and y. And then so u times v and y is equal of v u. So you have y minus integral of negative cosine y plus c. So and that's where you your c when you find your g. So initially y, and then you get your c from g of y. So when you integrate that, you get your c. So g of y is equal to y sine y plus cosine y plus c. So now when you put in g of y, 1/2 x squared plus xy plus, instead of g of y, you have y sine y plus cosine y. And then instead of just putting plus c, you could just make it equal to c. Basically, like you just did when you put it in for your solution, just put c instead of fxy. And that's